So, in this lecture, we are going to learn about the concept of damping. So, let's start by defining the term damping. So, damping is the property damping is the property of a system of a system due to which due to which it resists the relative motion. It resists the relative motion. So damping can be of various types. So damping can be classified into various types. So the first one is viscous damping. Second one is frictional damping, and which is also called Coulomb damping. And the third one is called material damping, or also called hysteresis damping. So let's understand the damping with the help of viscous damping. So let me erase this whole thing first. So here just consider this system here. So this is the representation of the given system. Which is which has this is the stop point, and this is the plunger here, and this system is filled with some viscous fluid. So this is the so this system is filled with some viscous fluid here. This is the viscous fluid. So this is the viscous fluid, and we are going to apply force F in left hand side direction to the plunger side, so that it is moving to this direction. So so work done by force, so work done by force is equal to loss in energy, which is equal to F dot delta X. So this is the work done by the force, which is equal to the loss in energy. So So we know that by applying any force to the fluid, there will be a existence of shear stress. So can be shear stress can be given by shear stress can be given by this representation here. So this is the profile of the existence of this shear stress here, which has the thickness y2, and which is thickness y2. So by Newton's law of viscosity, so by Newton's law of viscosity, tau is equal to mu dot du by dy. So tau is equal to mu into u2 minus u1 upon y2 minus y1. So at this point, there is 0, 0 from here to here. So at this point, the coordinate is 0, 0 here. So we are going to write this equation as mu equal to u2 minus 0 upon y2 minus 0. So we can see that shear stress is directly proportional to the u2. That is, shear stress is directly proportional to the velocity of the fluid. So from this thing, we are going to infer more things. Let me erase this whole thing first. So the shear stress is directly proportional to the velocity of fluid. So we can infer that the shear force, that is F shear, is directly proportional to the velocity of fluid. We can also infer that the drag force, that is F drag, is directly proportional to the velocity of fluid. And also damping force, that is F damping, is directly proportional to the velocity of fluid. So here damping force is directly proportional to the x dot, that is the velocity of the fluid. So after removing the this proportionality term, we are going to get damping force is equal to Cx dot, which is the velocity here. So here C is the C is the damping coefficient. C is the damping coefficient. So let's understand more. So the damping coefficient is equal to the damping force upon the velocity x dot. So we can infer that its unit can be given by Newton upon meter per second, and after further simplifying, we are going to get Newton second per meter. So in case of rotation, the damping torque is equal to C equivalent theta dot, that is the angular velocity. So here C equivalent is equal to TD upon theta, the theta dot. So the unit in this case is Newton meter radian per second, and after further simplifying we are going to get Newton meter second upon radian. So there are few keep in mind stuffs you should remember that so let me erase this thing first. So in case of inertia, there is existence of kinetic energy. So kinetic energy can be translational kinetic energy or rotational kinetic energy. In case of restoration, there is existence of potential energy. So potential energy can be due to gravity or due to the strain energy of the spring of the spring, that is half kx square. Now and damping in this case, and damping is due to the loss of energy. So we can say that by analyzing all these concepts, let me erase this thing first. So analyzing whole concept, we can say that vibration is nothing but conservation of kinetic energy into potential energy and vice versa. And it can happen with or without loss of energy. So this is the whole concept here. Now in the next two upcoming lectures, we are going to study about the linearization of parameters and lumping of parameters, which will mark the end of this second section. So for now, thank you.